I wanted to start with, so that you guys get clear on why we built your house this way, what the reasons were. And there were a number of them. One of which is we felt that Habitat needed to start looking at houses as a 100-year-long item rather than a 5 or 10 year or 20 year. And as soon as you start looking at houses as a 100-year thing, the cost of energy starts to become a really big factor, because the cost of energy keeps going up, and that defeats affordability. So by building a very energy efficient house, obviously it's going to help you guys live in it comfortably in the future. Another reason was the things that we've done to the house to improve its energy efficiency. Although they will raise your mortgage a little bit, you more than save the additional mortgage cost and energy cost.
Yeah.
So it's a better way to spend your money as far as I'm concerned, because you end up with a better house when you get done. The other reason is comfort. These houses historically are more comfortable than the way we have been building houses, and in particular the way we used to build houses. So those are the reasons. I wanted to start with how we used to build houses, and then we'll talk about how we're building houses today, and then how we built your house. 30 years ago, we built a house. The walls tended to be a little leaky. We put big windows in it. They weren't sealed up very well. They were leaky. We put light fixtures in. They would leak air outside. We would have vent fans that went straight outside. And when you turn the fan on, they blew hot air directly outside. And then we would put a big furnace to heat the house, pump the air all over the house, and many times even pressurize the house, which would cause it to leak all this heated air outside. We relied on what they call natural ventilation, which is when the wind blows on the house on this side, it creates a negative pressure on this side of the house and actually draws heated air out of the house. So that's how you ventilated the house. You just didn't worry about moisture because they were so leaky that the air change rate was so high that moisture in the house seldom became a problem. Then people started taking the older houses and putting viscreen on the outside windows and sealing them up, and all of a sudden moisture became a big problem.
Yeah.
So we realized that we needed to pay attention to that. And after that period, a lot of research was done. We built a lot of test houses, and the Washington State Energy Code was developed. The Energy Code created guidelines whereby we had to use better windows that would seal better. We had to use better exterior doors that weather strip better. We had to pay attention to sealing around outlets and some light fixtures to make sure that they weren't leaking as badly. So we stopped the air leakage, but then we had to pay attention to the moisture, because again, moisture in this house was a problem. And because of that, then we had certain size fan requirements that we had to put in for the bathroom fans. And many times you ended up having to put what they call a whole house fan, which was designed to run either all the time or so many hours a day, taking that interior air through the fan and blowing it outside. That's what ventilates the house, and ventilated the houses. Again, much better. Plus we increased the insulation from 2x6 walls to 2x4 walls to 2x6 walls. A little bit more insulation. More insulation in the attic, more insulation in the floor. But in general, all the little holes, the plumbing holes, the electrical holes, they were still there, and they still leaked at a fairly good rate. The Energy Code also required that we put some source of fresh air to get back in the house, either through actual vents in the windows that you could control, or vents in the wall that you could control, or in the heating system ducts itself that would draw a certain amount of air and be distributed around the house. worked fairly well. You had a fairly energy efficient house when you got done, but not as good as some would hope. So now in the handout I gave you is some comparisons, and this house over here on the end is a house built, let's say 30 years ago, before the energy code. And as you can see, the red bar, which is your heating costs, are pretty high to heat the house. The energy code that we have in the Washington State would be somewhere between these two here in energy usage. Obviously, your hot water heating and your general electrical use, for hair dryers or whatever, remains about the same, but the household heating has decreased significantly, almost in half. So it was a pretty good improvement. This one over here is your house. Okay, that's the goal we're heading for. We're not quite there yet, okay, but we're trying. And for us, it's a learning experience. But that's what we want to try to achieve, is to bring that heating cost down to a really minimal level. And then start looking at the hot water component, which is the tan one here, the lighter one, and what we can do to decrease that as well. Okay? So that's the reason. That's the difference. It's huge. It's a big difference. But I also want to set realistic expectations. You still are going to have some electrical heating costs. You will still need to spend money on that. We will be trying to separate and be able to track how much electricity you're using for heat, so that we get, because until we don't know whether it's succeeding or not. So, and that's part of the reason for this talk today, is that you understand how your house works. Because many times I see you build a really energy efficient house, and then somebody decides they like their bedroom cooler, so at night they have the heat on to keep the house at 70 degrees, but they have their bedroom window open to let in cold air. What? You got to choose. You can't have it both ways. Okay. So that's what we're trying to do here. So there's been a lot of research done in trying to decide what things to improve to bring the energy costs down. And there's no one thing. It's a whole bunch of different things. In your house, the exterior walls are 12 inches thick, as you know. And then I'm going to simplify it by leaving the second floor off. The attic upstairs will have about 24 inches of insulation up there, so it's very well insulated. Your concrete floor underneath the house has about 10 inches of foam insulation underneath it to insulate it. So we've created a lot of insulation all the way around the house. Then we spent a lot of time in caulk, as you two well know, trying to seal up all the holes to make it as airtight as we can. And one of the interesting things to both Josh and I was when we had the last blower door test, one of the assumptions has been is that the windows would be a big factor of the air leakage, and it turns out they're not. So for us it's a learning thing, and for you it will be a learning thing too. So we need feedback from you as you live in the house about what you like or don't like, or what's working and what's not. Okay? So the concept with the passive house and the house for your house is to insulate it really well, to seal it up really well, but now you have to worry about moisture. Yes. Okay. And moisture is a little confusing to most people and what it means. So do you understand what I mean when I say relative humidity? Good. So relative humidity is the amount of moisture that's in the air. Okay? And it's based on a percentage. At 100% humidity, the moisture turns into water. Okay? So if you have 50% humidity, it means you have 50% of the water that you can put in the air before it turns into moisture. Okay? And it's relative because it's dependent on the temperature. Okay? So the second sheet I gave you discusses it to a point, but the humidity level that you want in a house optimum will be about 50% in our area. If you were on the East Coast, it would be different. If you were in the South, it would be different. It depends on a bunch of factors. But what we're trying to shoot for is a 50% factor. And typically, if it's in your house here, if it runs between 50% to 60% relative humidity, everything's fine. So that's kind of our goal. But how do you know when you hit it? I don't know. You can't really sense it. So I'm going to give you this. And it's a measuring device that measures relative humidity. It's been in my pocket, so it's showing 77 degrees, which is not right now, but it's also showing about 52% relative humidity. Okay? So as the temperature changes, the relative humidity changes. Warm air can hold more moisture than cold air can. All right? So if it's 30 degrees outside and you bring that 30-degree air in your house, that once it warms up, that can hold more moisture than the 70-degree air you have in your house. So that's how you can dry a house out, is by changing that air with outside air, getting rid of the high humidity and ventilating it outside. So that's the goal.
Mom, let's go back to your room.
Oh, girls, you have to stay outside, sweetie.
Because Mom, I can have my shoes off.
Just a few more minutes.
So I'm going to resort to another drawing here.
No, it's okay.
Understandable. They're not all totally separated in your house, but essentially upstairs we have your bathroom and bedrooms upstairs, and you have downstairs you have a living room and a kitchen and another bedroom. In order to control the moisture and in order to move the air around the house, because that's important too, we use what's called an HRV, which is a heat recovery ventilator. It's upstairs in the mechanical room up there, and we don't have the parts we need to show you today how it works, so that will happen on a different day. But this device, this thing is really important to your house, and one of the things you're going to need to get it to work. What it does is, a heat recovery ventilator is a box with some fans in it, and it takes air from inside the house, runs it through a heat exchanger, and then blows it outside the house. Then it takes air from outside the house, blows it through the other side of this heat exchanger, and blows it into the inside of your house. Okay? So when it does that, it recaptures the heat at about 70 to 80% efficiency. So you do lose some of your heat. But instead of, remember the old leaky house where what was just going outside, and all the heat going outside, here you're recapturing that heat. And that's one of the big features for getting the house to perform better. So the device recaptures the heat, plus it ventilates, which is pretty cool. So the way we set it up in the house is that your bathrooms send air to the area, the heat recovery ventilator up there. The bedrooms get air from the heat recovery ventilator. Your laundry room and the bathroom downstairs here send air up to the heat recovery, where it goes through it and is blown outside. Then this preheated outdoor air comes back down and it goes to your bedrooms, and it also blows some down here to the living room. That's what that vent is there. There's one of those vents in each of your bedrooms upstairs. The reason we put them there is because at least 8 hours a day or a night, you'll be asleep in your bedroom. and your kids will as well. So that's the best place to put the fresh air. Also, most people are comfortable with the bedroom possibly being a little colder. Okay? So when you look around for heaters, you're going to see there's a heater, one of these wall heaters, in each of the bedrooms and in the living room. That's so that you can adjust them so that as that slightly cooler air blows in there and the temperature starts to drop because of this outside air going in there, the heater can come on and warm that room back up and equalize things out. It also allows for, like you guys say you want the room much colder than your kids do or vice versa or whatever, then you can adjust that heater and have your bedroom colder than the rest of the house. Although you'll find the house very stable in temperature. It's not going to be way colder in one room than it is in the other. It's just the way they work. And that has to do with the comfort level. I mean, sitting in here now, I think you can sense how quiet it is in the house. I mean, it's way quieter than it is in my house. From the outside noise. Yeah. But you can't do it because you're not getting the air in here that has the noise. And the walls are thicker. So, that air heat exchanger is a critical component to keeping the humidity down. Now you see on this handout I gave you, how much water does it take to raise the humidity level in the house? That's the question, how are we generating water? Well, if the interior temperature is 70 degrees, and your starting humidity is 50% humidity, that's where we want it at 50%. And if you add, and this house or apartment that they're using in this example is 800 square feet, which is smaller than your house, but not a whole lot smaller than your house. If you add a pint and a half of water to it, the relative humidity will go up to 70%, your danger zone. So you have to pay attention because it can happen fairly easily. The other chart or graph that I marked there, well, how do you generate that water? Well, cooking dinner for a family of 4 generally generates about 1.2 to 1.5 pints just in cooking dinner. Houseplants will add about 1 pint per day. Or 5 to 7 houseplants. So just houseplants. Obviously, people breathing. When we're breathing, we perspire, and our breath has moisture in it as well. We add to that. That's why it's important that the house be ventilated continuously. Okay? Is because that ventilation load, occurs continuously. So when we get done, your heat recovery ventilator will have 2 speeds in it. In the winter, and winter operation will be different than summer operation. During the winter, it will run continuously at low speed. Okay? So you just set it, and we'll help you figure out the programming. You set it up so it runs at low speed. Then when you use a bathroom or the laundry room, there will be a timer dial that you'll just turn. And when you turn it, it will turn it on to full speed. So then it ventilates at a higher rate. Okay? And not for 10 minutes. If you're taking a shower, you want to crank it up and let it run for an hour. To ventilate out the whole thing and ventilate as much as you can.
Same thing for cooking?
Well, cooking is slightly different. There's no pickup down here in the living room, kitchen area going to the heat recovery ventilator because grease is generated when you cook, as well as moisture. And you don't want grease in that air heat exchanger, it will mess it up. Okay? So in the kitchen, there will be a dedicated fan that blows straight outside. So when you're cooking, turn it on. All right? Hopefully it will be a quiet one. I don't know. I didn't choose it. But it is important that when you're cooking, particularly if you're boiling something, or whatever, that you turn it on and ventilate it out. Get rid of it right there at that source. Okay? So bathrooms, that is something you need to teach your kids when they use the bathroom, a bath, or whatever. Turn that fan on. Not for 5 minutes, but for the whole deal. Okay? You as well, so that we ventilate that moisture out of the house. As you decrease the temperature of the house, say like on my own house, at 70 degrees it might be 52% relative humidity.
Okay.
If I let it go to 60 degrees, it will go up to about 70% relative humidity. Because as that temperature goes up, the relative humidity, or goes down, the relative humidity goes up. Because it can't hold as much water. And what happens, if you get to that 70%, it won't all of a sudden turn into water in the air, but it will start looking for cold places, such as the windows, or the window frames, and condensing on those. That's why in a regular house, if you're sleeping in a bedroom and you get up, there's all kinds of moisture on the window and on the window frame. That's what it's doing. It's just reaching what they call dew point, where it turns into moisture because of the cold frame, or the cold window, or a cold corner. Most many buildings, the outside corners are very cool because there's not much insulation in them, and it tends to condense there as well. So that's why you want to pay attention to that. Your house, a good way to do it will be to look at this meter periodically and just see how it's behaving. That'll tell you if you're ventilating at the correct rate. And also you just start to see a lot of moisture on the windows. That's telling you what we need. Right. We need to ventilate it, the house a little bit more.
Okay.
And if you have any questions about it, feel free to contact Josh or myself.
Okay. Thank you.
Because for us, this is a learning experience, just like it's a learning experience.
Yes.
You are on the cutting edge of building science. Then when we get into the summer period, okay, where you can leave the windows open if you want to, because it's not right now, it's kind of cold outside.
Yes.
But when we want to, then you can ventilate with that. Again, you're going to find the house fairly stable. What you're used to is probably during the day when the sun comes out, the house starts heating up and gets hotter and hotter, so you're opening windows to ventilate all that heat out. You will probably find it better to leave your windows and doors closed during the day. The house will not heat up as fast. And unless you open the doors and let, it's 80 degrees outside, it's going to put that inside the house. So it's this kind of different way of looking at it. When you want to ventilate it is at night. When the air temperature is going to drop at night, then you open your windows before you go to bed and ventilate it to kind of cool it down at night, and then close it back up again. During the summer, you can turn off your heat recovery ventilator. It doesn't need to run at slow speed. For the months of, say, July through September, in that period, you'd probably be able to turn it off. At the slow speed, you still want it when you're going to take a shower. You still want to turn it on for that. Okay? And again, use the kitchen exhaust fan.
Yes.
Okay?
Yes.
So, the thermostats down here is over there on the wall, so you can set the temperature for what you want here. You can set the bedrooms at a different temperature. If you want the kids to freeze to death, turn theirs down. If they make you angry, it's super cold at night. But however you want to do it, okay? But the other component of that, as I've tried to explain, is if you let the house, if you decide you don't want to pay, it's too expensive to heat the house, so you try to let the heat come down to 70 degrees, that moisture is going to become a problem because its relative humidity goes back up again. So we know one of the other homeowners has been, first of all, they didn't open any windows and they quit running the exhaust fans because it was blowing all the heat outside, and then they turned the temperature down and let the house fall down to about 60 degrees. Well, it created all kinds of problems because the moisture started forming in the windows and every place else, and then you grow mold, and then it's a really bad thing. So we had to go in and tell them, you're better off to spend a little money and heat the house than you did, because that's what it's designed to do. But you don't have to keep it at 7. Again, watch this meter, watch how the house is behaving. If that's saying 70%, but you're not seeing any moisture on the windows, you're probably okay.
Okay.
All right? But above 70%, then I start worrying about it. All right? I think I'm done. Are there any questions?
So are you saying, Mike, that 70 degrees in the house is kind of the optimal temperature to maintain year-round to keep that 50% humidity?
60 to 70.
60 to 70 degrees in the house. Okay.
Yeah. The other thing is you won't see the temperature in the house change a whole lot.
Okay.
I mean, because it doesn't leak much heat.
Okay.
So at night, unlike my house or a typical house where you turn the furnace down and in the morning it's 61 degrees, you're probably not going to see that here. Your heat loss is going to occur through the heat recovery ventilator and just the temperature difference between the incoming air and the outgoing air. You lose some heat there. Okay?
Great. I have a question. So they have to be like all the fans like that. Like you know how it's up there and nobody's here. They have to be the fans
temperature the same. Can they be different? Yeah, like
You know.
okay, like if it's cooler down here and they want it warmer up there, is that gonna be okay?
They have
Or
to
would
be
that
options.
cause? Cause
Yes, you can.
okay.
It may not. It may be hard to maintain.
Okay.
And I don't know for sure, because again, I haven't lived in this style of a house.
Okay.
One of the issues that they've said from a comfort level is it's very difficult to get the house to be 2 degrees temperature difference room to room.
Okay.
Okay? They tend to remain very stable throughout the entire house, upstairs and down.
Okay.
The difference being is if you close the door to the bedroom, that heat recovery ventilator is running all the time. So if you turn the temperature down, that's going to continuously slowly cool the room down.
Okay.
So that might allow you to cool it off if you want to. If you run the bedrooms cooler than down here. Again, try and see.
Okay.
I don't know. You certainly won't hurt anything.
Okay.
Okay?
Yeah. I'm just learning how to use it.
Right,
Yeah.
yes. When we get the controls for it, then either Josh or myself, probably Josh, will walk you through. There's filters in that heat recovery ventilator that need to be changed periodically.
About how often?
That I can't answer. Probably twice a year, the same as a furnace filter. It depends on the people in the house, actually, and how much dust you generate. Yeah. I'm assuming with the kids, the door will be open and shut.
Yes.
So the one other thing I wanted to mention, because Josh brought it up as well, is you probably noticed as far as what we call operable or windows that you can open, there really aren't any down here other than the bedroom window. So during the summer, when you're trying to cool the house out, it helps to have create what they call the chimney effect, which is if you have a window open downstairs and a window open upstairs, the hot air tends to drift up and go out the upper one and draw cooler air in the basement. Well, it's difficult to do that here. So one of the things you may want to look at is putting a screen door on either this door or the back door, so that you can leave it open or partially open during the summer, and then a window open in a couple bedrooms upstairs to start to create that cooling, the chimney effect, when you ventilate the house. The bedroom window down here and a bedroom window upstairs with that bedroom window door open will probably do the trick. It'll probably be good enough. But again, you're going to have to try and see, because we don't really know.
Yeah. So I can try one of fans myself. I mean, like, no, you do, you know that.
So like right now, yeah, we use like would we be able to use like a fan?
You can use anything you want.
Just to,
Yeah, you can try it. Moving the air around.
okay.
And this is hot. But yeah, like that's too hot and it's too hot and I have to like turn off the fan.
Yeah, a fan will help move air and it makes you feel cooler in the house.
Okay.
That helps as well. And certainly, anything you've done before, try it and see, both ways. I can't say.
Yeah. Okay. Well, like, you know, like, when it's hot, like 80, you know, like when it's like July, it's hot, you know, very hot.
Yeah. When it gets 80, if the house gets up to that temperature, then obviously you're going to want to open the doors and all the windows and ventilate anything you can to get comfort. Absolutely.
But
And don't lock yourself into an 80-degree room on purpose. No. But what you may find is that, particularly if you ventilate the house at night, it may be 85 degrees outside and 72 degrees inside your house, so you're better off not to open the windows.
Okay, yes, better just keep it.
Again, you have to pay more attention to what's going on outside and what's going on inside. But it's all pretty common sense.
Okay. Like right now in the mornings, like if it's hot, we open all the windows early, and then just we're just we're just not used to
Yep.
having to worry about the humidity as much, so we just open
Well,
windows.
if you open the windows, you don't have to worry about the humidity,
Okay.
because that'll all be blasted outside. It's only what your temperatures are and what area, if your area you're bringing in is hotter than what you have inside the house, then you don't want to do that.
Yeah, it's no point opening
So
the
that's more than important. Okay,
Okay,
great. Anything else?
that's about it.
Okay.
Just now we just try it
So you
out.
guys probably want to continue living here. You don't want to like go to my house and live for a while. Live here for a while.
You can try this again.
Anyway, good to meet you.
Thank
Good to meet
Good
you.
luck.
Thank you.
And we're looking forward to see how it works for you.
Yes.
Okay, no problem.
Thank you, audience. I hope you enjoyed it.
Thank you.